Hey guys, welcome back and to this our final section. Oh my goodness. Section 5, course summary and review. Learning objectives or the goals of this particular section are real simple. We are simply going to go over all the course learning objectives one more time, ensuring you've got all this stuff down cold. We're going to take 2 lectures to go through this stuff. First lecture here, we're going to cover up through triggers, so that will mean data type primitives, syntax elements, user-defined types, flow control, scope and error handling, and culminating this lecture with triggers. In the next and final lecture, we will cover procedures, functions, and packages, the heavy-duty stuff. Guys, let's jump on the inside and get started our review.
We began covering our learning objectives in Section 3, Language Fundamentals. Within that section, we covered 4 major topic areas: primitive data types, syntax elements, user-defined types and collections, flow control, and then we concluded with scope and error handling. Lecture 3 covered the primitive data types and elements of PL/SQL syntax. We started out by looking at 3-state Boolean logic. Remember, guys, that when you throw in those nulls, that things get a little squirrely. Best way to handle that is just go ahead and memorize that new truth table and never create a Boolean variable without assigning it a default value of either true or false. If you'll recall, we next learned how to compile a procedure with SQL Developer. Pretty easy stuff, just copy and paste the code into the work area and hit that Run Script button. Alternatively, select all with Control A and then hit that Run icon. Either way works fine. We next covered the PL/SQL primitive data types. Remember, Rick's opinion is that lobs in the database are never a good idea. Better to use that B file instead and store the actual file out in the physical file system. Also remember that there are multiple redundancies within those primitive data types because Oracle was around way before the ANSI standards, so both the ANSI and historical options exist. We concluded Lecture 3 by taking a look at some of the syntactical elements of PL/SQL. Pretty straightforward stuff, just a couple of oddities. Remember that the assignment operator is that colon-equal combination, and that all statements must end with a semicolon. Of course, this stuff is all pretty much second nature to you guys now because you've been using it all along through our real-world examples. All right, moving on to Lecture 4, we took a look at user-defined data types. If you'll recall, we started out very simply with the use of the percent row type and percent type as associated with a row from a table or a column from within that row. We then stepped things up a little by introducing the creation of your own record type and even the ability to nest user-defined types. Next came our coverage of V-arrays, really nothing more than arrays and or enumerations like you're accustomed to in other languages. Only thing to remember is that PL/SQL V-arrays are indexed starting with 1, not 0 like all of us think. If you'll recall, we concluded our discussion of user-defined types with a look at indexed by tables. These are going to be used all the time when we start looking at our real-world examples, as they're one of my favorites to use. Remember, however, if you're studying for those Oracle certification exams, that these guys are properly known as associative tables, despite what all of us programmers actually call them. Finally, remember that you can nest those user-defined types to any level of complexity, as well as intermix primitives and user-defines. Only word of caution I have is to be careful as to the size of your index by tables. You put them too many rows in those guys and you can kill performance by eating up the entire SGA. All right, we then moved on to a quick review of Lecture 5, wherein we looked at PLSQL flow control. We, of course, started out with the proverbial discussion of the classic if-then-else. Very standard. The only weird thing here was this spelling of else-if. For some reason, the E is missing. Always trips me up when I'm playing with not paying close attention. We then, of course, moved on to the case statement. Again, very similar to what is found in most programming languages and very common stuff. We then moved on to loops. More specifically, we took a very brief look at a simple and while loop examples and then longer looks at the for loops. In particular, we checked out 3 different types of for loops. First and most simple is the for loop with an explicitly defined loop control variable. For example, for I in 3.5 loop. Remember how we had to use modular arithmetic to change the default loop control increment value of 1. If you don't recall that, you should probably go back and take a little look at that code because that's important. Next, we looked at explicit cursor loop control situation wherein the loop iterates through all rows in an explicitly defined cursor. Finally, we looked at an example of an inline view wherein the select statement is actually embedded within the for loop syntax. Very common practice and nice because it's relatively self-documenting and in general my preferred methodology. In Lecture 6, we wrapped up our fundamentals section by taking a look at both scope and error handling. You'll recall the scope of a variable refers to that portion of the code over which a variable is both seen and maintains a consistent value until reassigned. In our package body example here, we began by declaring a global variable elegantly named myVariable, and we assigned it a global value of package. Within the scope example 1 procedure, we did nothing to reassign that value or redeclare it, and as such, we print it to the screen we see the value package. Note, however, that within the declaration of block scope, example 2, we override the globally scoped variable and reassign myVariable a value of modified in example 2. Also note, however, that the first executable line of scope example 2 procedure calls a nested procedure called scope example 3. In this guy, we again change the scope of that myVariable by reassigning it the modified in nested value. Finally, note that as we leave the scope example 3 procedure and return to example 2, we're now back within its variable scope and thus print out the value modified in example 2. Guys, take some time and restudy that if that didn't mean much to you because that's important. Be careful reusing variable names as it can and will change the scope of that variable. My rule of thumb, don't reuse variable names within a package or even within nested routines. Just too dangerous. Okay, Lecture 5 next went on to describe the 2 types of errors which can occur in a piece of PLSQL. Of course, syntactical and logical. Syntax errors are typically pretty easy to fix, and we learned how to do that within the procedure editor. Simply compile the routine for debug, and the routine compiler gives you a nice list of the errors and on which line number they exist. Also gives you some possible suggestions as to remedy. Remember to open that procedure editor. All you do is double-click the associated object in the left-hand tree of developer. Lecture 5 then went on to discuss logic errors. Hey, we're all coders. We know the deal here. Bugs. Yeah, it runs, but it's not behaving correctly. Solution, developer's debugger. You don't know exactly how to use it, simply start playing around. Behaves very similar to all the other debuggers out there. Finally got that code working as you expected in Developer, you probably still want to include an exception handler in the code just in case something strange happens. Me, I use SQL error message and SQL code during the debug phase and then throw a generic, call the DBA message during production. I know all your college professors and Oracle say to handle exceptions specifically, but hey, they never had to actually write production code. Remember, those Oracle error messages are not generally appropriate for end user consumption. Please buffer them from that mess. Alrighty, that concluded our discussion of PLSQL language fundamentals, and it was finally time for us to move on to Section 4 real-world examples. Cool enough. If you'll recall, Section 4 real-world examples included a total of 8 lectures. In the first 2 we covered triggers, the next 2 are on procedures, next 2 on functions, and then we culminated with the big boys and 2 lectures on packages. Great fun, and I hope very beneficial to you in your careers. We looked at examples which not only covered the learning objectives, but also gave you a good flavor of how PLSQL is written in the big world. We began our discussion of named database programs with a look at triggers. Remember triggers? Sure, that piece of PLSQL code which fires in association with changes to the database. With our example, that usually means DML statements. Remember this guy? The prototype for a trigger creation statement. Create, optional, yet always included or replace, keyword trigger, and then the trigger name. Next comes either the before or after keyword. That is, will this trigger fire before an event or after its completion? Next comes on or more DML specifications. Insert, update, delete, or update of a column list. Remember, you want to include more than one of these keywords? Just separate them with the OR keyword. Next comes on table name. That is, when, on which DML event, and on which table will this code fire. Next, optional on each row clause. Include this guy and the code is fired once for each table row impacted. Leave it out, the code is fired once. Finally, we can also include as part of our trigger event definition a piece of conditional logic. For example, only fire this trigger for an update row when the old value of column X is greater than 50. As we all know by now, we then move on to our declaration blocks, wherein we define data structures and/or additional local subroutines. We conclude our trigger with the actual executable block. We indicate the beginning of that block with the keyword begin and conclude the block with the keyword and the trigger name. Remember, it's always a good idea to include an exception handler as part of the execution block. If you'll recall, we then took a look at our first real-world trigger example. Before inserting a new row to the users table, make certain the password strength is appropriate, and then set the user ID to the next value of the user sequence object. If you'll recall, we first created, but then not yet study, a function called calc password strength. At this point in our studies, we simply stipulated that this function accepted a user-supplied password and returned an integer in the range of 0 to 100, indicating the relative strength of that password. Net, we are using our trigger to enforce business logic. If the password was wholly unacceptable, we simply halted execution and threw the control back to the calling routine. If the password was okay, but still not great, we went ahead and created the new user but then froze their account. Only if the password was good did we allow the flow to continue. Here we assigned the next value of the user sequence object to the user table primary key, that is, user ID. At that point, our trigger work was done and we simply allowed the Oracle engine to complete the actual row insertion. Did you remember our use of the new pseudo row as associated with an insert trigger? Remember, insert triggers have a new pseudo row, whereas delete triggers have an old pseudo row. Update triggers, of course, have both. Use dot notation to reference a column within those new and old pseudo rows. One more thing to remember from that example. Our sequencer continued to increment despite our rolling back each of our transactions. Yes, sequencers are immune to the transaction control commands. Finally, do you remember how we concluded Lecture 7 with an insert trigger when we actually included the insert DML? Yeah, that trigger is going to go into a recursive loop and eventually die of its own death. Common mistake made by every new trigger author. I would hopefully saved you one with that one, you owe me one. We ultimately then, in Lecture 8, spent the entire lecture discussing the dreaded trigger mutation monster. I'm sure you remember that mutation will occur whenever the DML within a trigger impacts the long-term state of the current table. For example, do so much as read the current state of the impacted table within an insert trigger. Boom, mutation, because the table becomes unpredictable on insertion of multiple rows. Have the trigger on table X read the contents of table Y, which in turn has a trigger which reads table Z. Ultimately, table Z now reads back to table X. Our trigger will make mutate. Net, complex logic belongs in packages, not in triggers. Hey, you guys understand transitivity. So does Oracle, and they are not going to let you put your database in an inconsistent state.
All right, welcome back, guys. I hope you enjoyed. Those of you taking the certification exam, it's especially important that you put all this stuff to memory. If you're just working in the field, you've always got Google as a resource out there, but it can't Google during the certification exam. So make certain you put all this stuff to memory. We'll see you in the next lecture where we cover procedures, functions, and packages. And then I talk a little about my next course, PLSQL and XML. Should be good fun. In the interim, you know my league. You go out there and you have some fun today, but learn something new because it's what's important.